passion, no prep.
That's how it should be.
Zach, welcome. It's been a while. What's the latest since we last spoke? Do you want to give an intro maybe for the team that's watching?
Yeah, for the team. Yeah, sure. Yeah, I'm Zach. I'm one of the founders and CEO of a company called Ultravox. We sort of train speech models, speech understanding models, and then we run like some voice AI infrastructure. So we basically take that model and then run it so people can build and scale voice agents. So what's been new since we last spoke? I guess the biggest thing is we're actually I think today we will hit the release in Hugging Face on the next release of the model, Ultravox 0.7, which is very good, I think, on speech understanding, but also got much smarter because it's trained. We officially said goodbye to Llama as our base model, which was the right thing. And the new model is built on top of GLM 4.6, which is a really incredible model, actually, that not enough people are talking about in the open weight class. And so I think for the first time now, actually, when you sort of normalize for latency, there is officially no gap between proprietary and open weight models at this point. On the frontier, there still is. But certainly in the usable for real time category, I think it's been thoroughly bridged, and so I think we'll hit the publish on that today, and then we got some new and more interesting work coming out hopefully later this month or earlier in January on sort of the next sort of iteration of models that we've been working on. So anyway, happy to talk about all of it, but.
That's pretty sick. Why did you guys change the architecture? Like GLM 4.6, what is it? What's the structure of the physics of the GLM series, let's say, that's different from the Llama? Because you have a lot of options out there, and you clearly, you guys evaled your way to finding the right base. How did you pick that? Like, what is so special?
Yeah, well, I think Llama's just been dated for a while. Like we survived on like Llama 3.3 70B, which was a really good model when it emerged back, like a year and a half ago, which I think in like LLM years is a decade in terms of like elapsed time and
depreciating.
Progress.
It's a depreciating asset, very
and then
quickly.
Exactly. And then, of course, Llama 4 was such a bust. And so we've been on the hunt for a while. I think, and we were sort of trying to figure out what should be the next model for us. I think the biggest challenge was that what we saw was a lot of the open weight models would look very good on benchmarks. But then when you would go to actually like run them in cases you actually care about, which is like, and voice AI is really interesting because it's very rapid, like conversation growth, like as in like it's very short utterances that happen, and so the context grows quite quickly. And then what you're sort of measuring oftentimes is like, okay, well, what's the performance of the tool calling or instruction following in this very rapid sort of conversational style? And what we saw was that like a lot of these models that were clearly benchmark maxed in terms of like their performance. And so like the evals would look great, but in like our evals, we have like an internal eval called Voice Agent Bench, which is a bunch of like measurements for like how do you perform across things that we tend to care about and customers tend to care about. They all just kind of sucked actually. And until basically GLM 4.6 though was a really great one on the scores. So much that we didn't quite believe it at first, but it's continued to sort of bear fruit there. But it's also much larger. I mean, Llama is 70 billion parameters, 3.3. GLM 4.6 is I think 355 billion with like I think 120 experts something per layer. So it's just a substantially larger model. And like that also introduced complexity on the model training side and like how do you sort of because the way Ultravox works is that there is no transcript. I think maybe not everyone knows that. Like we want to sort of train the model to understand audio natively. And ideally we want to do so in a way that doesn't hinder the performance of the underlying model that we've chosen. Because it's very easy. When you go to fine tune a model, I don't know if this is obvious to everyone, when you touch a model, you make it dumber. Like invariably so. Like the act of fine-tuning something is sort of the act of like constraint to a particular purpose.
Catastrophic forgetting is a classic, one symptom of this.
Yeah, exactly. That's like the worst case, right? But what we really want to make sure is that when we train these, like the Ultravox, is that we don't hamper the reasoning, tool calling, instruction following performance. And so GLM certainly had some challenges, both in terms of its size, but also like the mixture of experts layers and stuff like that. But gradually worked it all out, and it's been great actually. So we're really happy with it so far.
That's super cool. I'm actually, this is a non-linear question, very change of topic here. How did you get into voice? I think you were PMing at Google, Shopify were the most recent pieces? Like, what was the origin story? Um,
Yeah, yeah, it's a good question. We
and why
started.
pick the speech-to-speech bet? You know, there's lots of other bets. You can do orchestration, you can do
Yeah, yeah,
TTS,
yeah,
SCT. There's all these different
yeah,
places, and I think you've differentiated in a pretty unique way. And I don't see a lot of other people
yeah,
pursuing an open weight speech-to-speech kind of
yeah,
first
yeah.
strategy. So I think there's lots of uniqueness here that I'm really interested in.
Yeah, I mean, I think yeah. So my background is in like software engineering, but for the most of my career has been in like product management for the most part. So spent a lot of years on Chrome and then on Android, and then like led some developer products at Shopify. But really had an itch to start my own company for a long time, and so 2022 rolls around and start sort of exploring some ideas. Had sort of was sort of had my like holy shit moment, as I call it, with GPT-3 sort of fairly early in 2022, and just being like, okay, I don't know exactly like what the right thing to build is, but it feels like LLMs should be a part of that story. And like not enough people were talking about these LLMs at the time, and so we first started off actually building like in a multi-agent framework on top of GPT-3. There was no tool calling yet. There's none of that stuff. But we sort of saw that future, and so we tried to build it. But it was just too early, I think. But one of the things that we had tried very early on was, like, oh man, these models are really, really good at like natural dialogue. Maybe we can finally talk to a computer like we talk to a human, and it won't be complete garbage. So we had built a demo in 2022, but it still wasn't very good actually. Like it was, I mean, good maybe for then, but very slow and didn't quite see a path. Like time to first token was pretty bad. ASR models were all pretty slow, and TTS engines also weren't great. And so we kind of like put that off to the side. But then by the summer of 2023, like ChatGPT 3.5 had come out, which was much faster. We had some decent TTS choices. Whisper, of course, had so we sort of put the pieces together, and it was like, actually, this isn't terrible. Like, let's keep exploring this. And so we ended up building the first version, like our voice setup, in the latter half of 2023. And so when we got to January of 24, we made sort of two big decisions. I guess one was that we're going to pivot the whole company to sort of focus on voice. We thought it was going to be a big opportunity, and like people were going to recognize that this was a really great way to interface with models and computers in general.
Was it a hard bet, or was it pretty obvious? Like, hey, we should really do this.
I think to
Like
us
it's
it felt pretty.
early.
By that point, it felt pretty obvious. I mean, we'd spent like 6 months, kind of like flirting with the idea, and then so 6 months in, we were pretty. It was time to go steady, I suppose, with the idea. We felt pretty convinced by the relationship. I think the more controversial one was that we were not only going to pivot to speech, but that we were going to basically throw away our orchestration stack, and we were going to become a model building company. And we did that because I think we felt and still feel that there was no path in the component stack to get the kinds of experiences that we wanted to achieve. We just felt like you were anytime sort of trying to pipeline these things together, and you have massive context loss, and you convert to text. It just felt like it was a dead end for us over the long term. And so we were like, okay, the only path is to actually build a speech model. And now that's been hard, and so we had to go build a whole new team for that and stuff like that. But that's kind of what led to that was the realization that if you wanted to get to this style, this like fidelity of conversation with an AI, right, that you and I are having, that had to be like sort of learnable the model had to learn that natively, and we didn't see a path to solving those problems in the component stack. Not to say maybe that's impossible, but like we couldn't see the path there, and so that was why we started doing this.
Got it. That makes sense.
Yeah.
Question then. I would say from what I see, the cascading stack is still pretty dominant. I think there are speech-to-speech deployments that I've personally seen. We've supported them on our side when we're testing them for hallucinations, tool call accuracy, and so on. Why hasn't maybe adoption been as fast? This is a leading question. Like maybe I'm projecting of what we see, right? But the data is cascading is still sort of king at the moment, and I want to know why that is, and do we think there's some sort of inflection point, maybe the 0.7 or maybe like 1.0 eventually will be contributing to the change of tide. But I really understand the mechanics here for why haven't speech to speech been the default way instead of I should also try speech to speech.
Yeah, I think there's probably a few areas. So I think number one is that, again, I think these gaps are closing very rapidly. In fact, like, so I'll say a thing and then I'll say the opposite. So I think for a while, going speech to speech meant getting probably better latency and better conversational performance, but at the cost of a dumber model. So, like, even if you looked at like real time from OpenAI, and if you were to sort of measure the performance of that on like take a benchmark like Voice Agent Bench or Big Bench Audio, what you would see is that if you compared it to the pipeline, you would see degradation in performance, degradation in terms of reasoning performance, degradation in tool calling, and it turns out that like those things matter a lot for end customers, right?
It's like enterprise. It has to be natural, but it has to work.
Right, and so I think you saw probably a faster adoption in speech-to-speech on like use cases that were much more conversational in nature, like companionship-y-esque things, and certainly less so on, let's say, more, I don't want to call them but like IVR-esque use cases where it's like, here's a very clear step-by-step thing you need to do, collect this, then do this. So I think that was the case for a while. And I think that's just because, like learning to train these models like takes time. I sort of think of it as, we should look at other modalities like as a comparison. Like go back 2 years ago to video generation models. And you remember that model of like Will Smith eating spaghetti and how terrible it is. And then look now at like what you get. And it's just remarkable progress in the span of that time. And what's happening under the hood, I think, is that we're just getting much better at constructing world models for the thing that we care about. So like, we have these foundational text LLMs that have a really great world model constructed on text. We've now got really great world models for images. We now have really great or increasingly good world models for video. That's what creates like those physics effects that seem real. The model's just like learning better about these things. And I think we're sort of solving the same problems on the speech side. It just, you sort of have to iteration your way through that. And so it was a very rational decision like 12 months ago if you had to get to production level outcomes, the orchestration model made complete sense, I think. I think we're at the point now where there's actually no trade-offs. And in fact, I think that like with 0.7, for example, I think not only does Ultravox perform well against other audio models, but now it is completely on par, if not slightly better, than the cascading architectures as well. And you get better conversational experiences. But again, like that's taken us a long time to get there, right? I mean, that's just the truth of it. And so I think that's probably a big explainer, is just that. And then I think there's small things that tend to come out on the other side as well, like where on the to-speech side, people really like their voice clones and their sets, and oftentimes the speech-to-speech models don't allow you to do that. Like OpenAI, you can have any voice you want as long as it's one of like their built-in set of 6, whatever it is.
The Ford.
Yeah,
The
Gemini Live has the same thing. And so now you're stacking problems, right? Because now you've got to figure out how to solve speech understanding, but also do like zero-shot voice cloning with it. And so these things just take time, I think, is what's happening. But I do think that we're at that point now where, like, there's almost no trade-off with going to speech, or at least like speech in and then something else out. And so yeah, we'll see how the next year shapes up. But I suspect like things will start to arc a little bit differently.
That's cool. I had a conversation with one of your customers today, and he was pretty happy with Ultravox. And so, customers spot in the wild when people kind of show up.
Yeah. That's great. And look, I'll be very frank. We had a big threat, I think, as a company for a while, given our dependence on Llama 3.370B, right? Which is just that like the gap between, say, like GPT-4o, let's say, which actually kept getting, we think of it as like one model, but they do lots of updates, right? And 4.1 from OpenAI, these are fast models that are also good. And if you benchmarked those against Llama, it was clearly that Llama was a worse model. And so I think our customers had to make sometimes this like difficult trade-off between, hey, do I want I think your guys' conversational experience is better, but I'm also finding the model a little bit dumb. And that's a really crappy trade-off to have to give. And so we've had a number of customers now on our 0.7 preview for the last, I would say 45 days. And I think it's sort of, people have been quite happy with it. And so hopefully that continues to, I'm sure we'll discover other bugs. That's the nature of the game, the nature of the beast. But I think things are trending in the right direction there.
That's cool. Well, maybe not why. This is more of an observation. Again, I might be ignorant here. So, to some extent, a lot of the progress depends on open source models getting good and the team having this just tide being lifted over time, and then having the native audio in, audio out training that you do.
Yeah.
What's the limiting factor? Is the limiting factor the tide, or is the limiting factor the efficiency of how much kind of juice you can squeeze per architecture? Like, how do you fundamentally think about that?
You mean in terms of like what's blocking us from getting to like perfect human level conversation or whatever?
Yeah, just like input outputs, just the input outputs here. Like, what is the thing? Do you just need more data and you just scale it up? Is scaling problem for you? Or do you need more breakthroughs to actually happen at the architecture layer for this to be more, I think, dominant and default choiced?
The way I think about it is, what do we need? I think there's probably different like sort of goals you can set. But like, let's imagine, here's like my forever test I want to be able to pass, right? So let's say that, talking to you and I say, your name in 3 different ways. I've got like, Sumanyu? Sumanyu. Like, I mean, you know immediately that each of those merits a separate response. It's very intuitive for us.
Yes.
No model in the world right now is even close to getting that level of granularity. Like, why? It's worth sort of thinking about like what's hard about that problem, and I think that there's a couple of layers. So number one is that we really are trying not to have to like rebuild an entire foundational world model from scratch. It's very expensive, it's very hard, and we already have really great like text models out there that have phenomenal world like models in them. They understand what happiness and sadness are. They can solve problems. It feels very stupid to go recreate that. And in fact, early experiments like back like a year and a half ago tried to sort of train foundational speech models just like text models, throw shitloads of data at it, and it was always bad. Like, because A, there's just less data, there's more variation, so like they sounded like bad and they were stupid. So that wasn't a great, and so our stance has always been, how do you like piggyback off of that, the fact that these teams have already built really great world models, they just don't know what the world sounds like. And so how do you align these representations? And I think that's really what Ultravox is today in some sense, right? Is that we train the model to sort of align the spoken form with the text form. And that's what allows us to leverage the intelligence of the underlying model but still in audio form. But if you think about like kind of what has to happen, like in that example I just gave you, where like we say someone's name a little bit differently, like you have to sort of carry that through all the way through the network. Right? In other words, like the way I give you the input derives your output. So this is why like models are so stupid and they don't get any kind of sarcasm or nuance here. Because like the way I feed you the input is driving the way you're going to produce the output. And that means from like, if you think from a network standpoint, like that has to be carried all the way through. Because like if you're trying to figure out a response, but at the beginning of that you don't carry through the input like signal, then it's hopeless basically. And so I think that these are just hard problems to solve. Right? You've got to sort of align these representations, got to figure out how to carry that through the network. You have to do so without hurting the model. And so I think that we are a number of like sort of research solutions away from actually getting to full fidelity. And then of course you have the full duplex problem, right? And then it's worth really thinking about what is full duplex under the hood? Like clearly you still need an inference step, but you're still listening. So I think there's just a lot of really interesting hard problems under here. And it just requires sort of teasing them apart, experimenting. But also, just at least for us, like we want to get it out there and provide value in the interim as well. And so, like I said, I think that 2026, I think there is zero trade-off in going to a speech-to-speech system for the most part. Like you get just as good of model reasoning performance, all that stuff. And hopefully, and I think throughout 2026, we'll start to sort of see things that are only doable in speech-to-speech systems. I think it's a short list today, actually, honestly. Like some companies will claim like emotional understanding. It's not real. You can give a little test. This is my favorite. It's like ask the model to play a game. And certainly if you understand emotion, you understand whispering versus shouting, right? I'm always like, let's play a game, okay? And so let's say ChatGPT will be like, let's do it. And I'm like, okay, you tell me if I'm whispering or if I'm shouting. And I just talk normal, right? And I'm like, okay, what am I doing now? And it's like, ooh, that's definitely a whisper. And you just keep talking like, that's definitely a shout. So like, they're just pure hallucination. I think these are just purely unsolved problems, at least today, for what's out in the wild. And so I think we have a good line of sight on what it takes to solve them. But certainly it's still in theoretical training, does do what we want land. So.
I see. So so what I'm hearing is, just so that I understand, a lot of the card flips that need to be true for this to be default on is largely in your control, as in the inputs very, very clearly to influence the final behavior. There's obviously some question, and then like, greatness, step 4, right? There's like some kind of chasm, but it feels tractable is what I'm actually hearing. Like it's like very much tractable, a matter of time.
I think it's tractable. I think for sure. I think that we feel more confident than ever about. Like, I think the exact shape of the input data and like, is it this or like, what you really want to do is like, how can we do larger unsupervised training runs as opposed to supervised training? That's how like models we learn today. Yeah. I think like all that sort of is like in the needs more experimental sort of validation. But certainly the early outlines seem quite positive there on the unsupervised sets and again, we talk more about model architectures. I think our minds has also shifted a little bit on how the ideal architecture will end up looking like. But yeah, I think that the pictures the map is becoming clearer. It's a little bit granulated, and it's slowly sort of like it's like watching
more
the
soluble
play out,
yeah,
right?
It's more
slowly, it's coming into more and more focus with each iteration. So
that's cool. One thing that we've noticed, and a question for you, I don't know if 0.7 solves it, but when we test speech-to-speech, they're generally much more sensitive to background noise and other aberrations and crosstalk than maybe the cascading stack. And this could just be an artifact of the styles of Asians we've kind of tested. But there's definitely, speech-to-speech definitely has different kinds of failure modes that it's more particularly sensitive to while being more natural. So I'm wondering, does that change over time? Does that simply get better over time? Or more, as the models get more capable, the failure modes also keep changing, but they still will always be there in how someone might exploit them, for example, for kind of innocuous or more adversarial, let's say.
Yeah. I actually don't know if it's true that speech models are any more like sensitive to noise interruptions. I think that's just an implementation choice. Like the great hilarious thing is that guess what sits in front of a speech? Like you can have the world's fanciest speech-to-speech system, and guess what sits in front of it? Like a stupid VAD system, right?
Yeah.
Like that's what's so funny. Like that's what's so funny is that we have these 355 billion parameter models that are very smart, but the thing that sort of sits in front of it is like this very simple VAD.
Energy-based
exactly,
kind of
right?
detection mechanism.
Yeah, and so I actually think what's really happening here, because I don't care if you're OpenAI Real-Time or Ultravox, like we have a VAD, like we have a simple energy level VAD. And then behind that, of course, we have another open source model that we call UltraVAD, which is like a contextual semantic VAD that tries to take into consideration context. And it's also audio native. And both those have to give a true signal. And then the model itself is trained against sort of the resilience of background noise. But I think this is an example of a problem for like, why do you ultimately have to have speech-to-speech? Or at least, I don't know if like the to-speech, but you certainly have to have native speech input. Like, I'm guessing a very common failure mode that you guys will run into is like someone is talking in the background of the call. And now here's like a really hard question to know is like, let's say someone puts you on speakerphone, right? And there's a primary speaker and then there's someone speaking, but they're roughly equidistant from the speakerphone, right? For humans, we can navigate this just fine. I don't think any system today can handle this well. It doesn't matter if you're like a cascaded system at all. So I actually think what's happening here in practice is that when you go to integrate the speech-to-speech systems, they've optimized and tuned their setup for a particular type of outcome. They've tuned, let's say, for low background noise, rapid phase, natural colloquial conversation. Like if you look at like OpenAI, I suspect they are like most of their time is spent appealing to a consumer audience, not trying to sort of build highly productionized speech-to-speech workflows.
Yeah, optimized for QSR, other more kind of noisy, trickier kind of domains
Right.
intrinsically.
Right.
I totally
they-
understand. Pre-processing matters. Pre-processing definitely matters, and having a rig really matters. I think it's more of a comment of just the sensitivity we've noticed on.
But I guess my point is like that. There's nothing magical like that. That's different on speech. They're like the things that drive the sensitivity are just actually heuristic
That makes sense to me.
choices in front of it. You know, like there's almost and like again, it's bad that this is the case because like what you really want is you don't want fad. Like you don't want to have semantic fad. You want like that's what we do. We have a brain that's deciding all the time. So you may still have VAD in there just to like not waste cycles of like GPU inference cycles if no one's talking. But it's certainly the case that like we use all of those signals as humans to derive meaning. And so we think over time, it's like right now you can think of like the number of components to power these systems like grows. But over time it should go away. So for example, like take like noise cancellation systems. Like we're pretty sure that like those are kind of useful right now, but also problematic. And then what you really want to do is get rid of those. And so for example, like we don't like no noise canceled audio goes to Ultravox anymore. We find it's too problematic actually because you're now like the real world doesn't have noise cancellation in it, and so if you're training in like on real world data, like it actually hinders model performance. And so all these trade-offs like sit there in the middle right now, and I think that's sort of where it sits right now, and people make different decisions on how to tune those heuristics basically. So I think that's what's happening is my guess.
That makes sense. I think this reminds me of Common Crawl, like the OG GPT-3 maybe. Data prep was a big deal in compressing down maybe to like 3-4% of useful things that are actually amenable for the next token prediction to work. And it seems sort of funny if you pass in really, really clean data to an audio model, it's sort of worse because it doesn't generalize out of sample, because the real world is not perfect, right? Like if you perfect in, perfect out, amazing. But the real world is not like that. A lot of ums, ers.
Exactly. Exactly. The real world's very messy. You want real world data, and you want the model to be more resilient to that. And like, we've done lots of experiments here. Some successful, many unsuccessful. I think on trying to figure out like how do you build a more resilient model. But I think this is where I think over time, again, we just look to like other. I think these are all solvable problems, assuming that we can get the right data sets and stuff like that.
Got it. One question I have, and again, this is maybe just ignorance. I'm just trying to learn how you guys run experiments internally.
Yeah.
Are there experiments that, or like, is it pretty obvious directionally what will work? As in, is there predictive power in experiment selection, or are a lot of learning is novel and emergent, where maybe with GLM 4.6, you've actually discovered that, hey, actually, like it's like pretty good at this that we thought would have been difficult. This is mostly around prediction capability of experiment selection and how random is it?
Yeah, so we should get ZQ in here. Like he's like my chief scientist who leads all of these. I think, so I'll give...
It's a DS question. I'm a data scientist, I want to know.
Yeah, I don't even know if I have the perfect answer. I think like, in some ways, like the current Ultravox model sets are like fairly well understood for us at this point, like how they're trained and how to. So I feel like oftentimes it's more like the experiments are us like, hey, can we hill climb a little bit better if we shift from this to this, or like you've got like batch sizes and stuff like that, and those I feel like more like they're driven by underlying intuitions and sometimes you get pleasantly surprised, but again like it's a fairly well understood space for us at this point. I think the work that we're doing on sort of more foundational speech model stuff that I think will come out next year has been very different in that regard, right? I think that that one is definitely much more greenfield, right? These are like, I think we're trying to figure out very novel ways of solving these problems, not for the sake of novelty, but just for the sake that like of how we're gonna like produce better speech models. And I think that's been like a combination. I think we start with like a hypothesis always, right? That like, hey, okay, could we do this type of loss function here, here, here? Like, and we've learned a lot. I think our ideal speech architecture has shifted dramatically in the last year. I think if you like looked at a Notion doc that we wrote in January of this year for like what we thought the architecture was going to look like, and you look at like the architecture that's in training right now, like radically different. Like I would say we got 60% of our assumptions wrong in terms of what the final shape approach was going to end up being. And I think that's largely been driven by trying to go build that thing and then like running these experiments and being like, well, that didn't work at all. Like that is garbage. And just thinking more and more, I think that's just like, yeah, I think that's normal. I don't know if that perfectly answers your question, but like, I definitely think there have been some things that we've been very pleasantly surprised by. And some things that we've been very unpleasantly surprised by. Like, oh, in theory, this should work perfectly. Why is this not working? Right? Like, why is the loss function such a disaster? Like, why is this loss curve?
Yeah.
Like, this doesn't make any sense. Or like, wow, the loss curve is beautiful, but the end result is garbage, you know? Like, okay, clearly that's not the right thing. And so that's been very interesting to me.
Got it. So it's very high variance. It still feels relatively high variance, right? If between Jan and kind of December of sort of learnings the team
I
is
think
getting.
just like you want your loss function to stabilize in model training, I would say that like we are also sort of stabilizing as we get toward the end of the year, and we really started to stabilize, I would say, over the last like 6 to 8 weeks.
Got it.
You know, so I think a lot of people, you know, in our Discord, they'd be like, you know, hey, when is like the two speech? When is speech to speech coming? And we were originally like, hey, we have a pretty clear line of sight, February, March. And then we got it and we were like, actually, we think this is all wrong. Got to throw all this out and start from scratch again. So sorry about that. But I think for hopefully better outcomes. So yeah.
That takes courage. I feel like that takes courage. I would say for us, we maybe not research, but more product engineering, ergonomics, DevX. We got a lot of things wrong. I think towards last year, and I had a decision I had to make. Do I continue chugging along and kind of limping along in this status quo? Or do I hard rip it out and actually reset from the ground up and rethink from first principles? What do we know now that we didn't know before? And what should be the right kind of shape? I hope not to do that again, but you know, it's sort of reality, you know, is like you're sampling the world and you're also learning kind of what needs to be true.
I think a lot of people that have never don't know how hard it is, because like, you know, because in the moment you're very, very zoomed in, right? And it's very hard sometimes to zoom out and look at it holistically in the way that I think you just described. And I'm guessing you felt this too. Like in hindsight, you're like, obviously that was the right thing to do, probably.
Yeah.
You're like, obviously we got it right. We should have reset it. That was the good thing to do. But in the moment when you're so zoomed in, it's very, very hard, I think, sometimes to make that judgment call. And so I'm curious, like, what helped you make the judgment call? Like, what was the signal to you that, like, I shouldn't keep that, I should rip? Like, what was it?
It's just a feeling. I think you look at reality on the current path and you're like, I'm going to die. Like, I will get crushed if I just continue down this path. Whereas I might have to take 5 steps back or 10 steps back. And maybe tell customers to pause or tell them, hey, look, we'll be ready for you a little bit later. But it just felt like, you know, doing the right thing, I think is very important. Things I learned at Tesla was Elon will just make decisions, you know, shut down the stores, reopen the stores, these like very dramatic decisions. But it comes from a place of having conviction that intellectually it's the right thing to do. And now you have to deal with emotions and the implications of seeing the truth and actually just committing. So I think my training maybe makes it easier for me to suspend emotions and just follow the truth and truth seek kind of all the time, even if it means losing temporarily. But we J-curve very deeply out from that point. It would have been a disaster if even one more month would have been like the wrong thing. Because it's one more month forward, but then 2 months backwards.
And this was sort of before you were into the voice AI sort of evaluation stuff, but this was part and parcel? Like, tell me more. Like, what was the...
It's connected. So we generally have had a trust safety bet. I think we weren't sure what's the right market to go after. So it's a little bit of a problem or a product searching, a solution searching for a problem. We found the right problem. A lot of it was monkey patching and kind of hacking our way to just contorting it to make it work. And I think we got like some progress and traction from that. But really, what we should have done is reset much earlier. If anything, I would regret. My regret is I didn't reset fast enough. I should have done it even 3 months earlier.
So it's always fun with this, right? I think like maybe Elon is one of those, like, from what I've heard, rare people who like doesn't have that problem, who like once he has like the inclination just like goes on it. But I think we wrestle with the same things all the time. And I do all the time, right? I mean, it's also just a fast moving space in general that I think it's always good to constantly be revisiting your priors and. Again, I think being able to like sort of throw your baby out. I have a human baby that I love very much that I would never throw out, but I don't have the same. But for technical products, I'm much happier to toss. So, yeah,
That's crazy. Yeah, I mean, there's a whole, I think, segment maybe around that dwell time. I'm actually curious, how fast did you guys end up going from, like, how fast did you go from knowing, hey, this is sort of the wrong direction, or actually having an idea for a better direction, and then taking the action? What was that dwell period?
yeah. That's a good question. A few months, like for sure. I think, like, honestly, there's even another version which is like, okay, do we even keep going after this, right? Because you could, like, we have the Ultravox model today, right? It does a good job of what it does, right? It's very fast. It doesn't have a transcript. We have happy customers. So there's one world in which you say, do we even need to go do the next phase of this? Like, could we just stick here? And I think we wrestled with that actually as well. Like, once that first one isn't like obviously proving as fruitful as what you want, you sort of, at least we sort of paused and said, hey, is this where we want to be at all? Like, should we be doing this? And I think we wrestled with that decision for a
Is
bit.
the juice worth the squeeze? It's a classic. Like, hey, is this worth it?
Yeah,
If it's
exactly, right? Because it's very hard, it's very expensive, it's very painful in some cases. But I think ultimately for us, and so I think we probably dwelled for longer, like just like probably longer than we should have. And then I think it became, but when it snapped into focus, it really snapped into focus. And it was like, no, obviously this is yes. Like, you, again, like very zoomed in, you got yourself sort of talked like into all sorts of different permutations. But zooming out, it was like, oh, what are we talking about? This is obviously the right path. Like, reset, let's go do it. But that probably took a few months, is my guess.
when did you guys reset? Like, what was the rough
Oh, I mean,
Q1,
like,
Q2?
I guess like we probably sort of wrestled with ambiguity throughout Q2 is my hunch. Looking back, like Q2 was a period of like, do we go for this new speech foundational model? Do we not? What have we learned? Like, should we do it? And then I think by Q3 it was coming to more, and so by mid Q3 it was like, this is stupid. 100%, we know what to do. But in some ways, actually, maybe there was benefit in the pause, because I also think that in the pause, as we wrestled with more and more of what to do, a few other things came into focus about how to do it. So I don't know. It's always so hard to know, like, should we have done it earlier? Maybe we would have made the wrong, I don't know. But we definitely, I would say, at least a quarter of solid wrestling with like, oh God, like, what should we do? And it's probably tied to, like, again, you're a startup. You have to make hard decisions about where do you invest your time, energy, resources? Like, where's the juice worth the squeeze, bang for the buck? Like, you pick your sort of meme of
What
choice.
doors do you close? Right. What doors do you close? If you open a door, there's always a price of opening a new door. So what doors am I closing right now if I open this door?
What are we well positioned to go do? Like, are we being insane? Like, are we being insane to go even try to build a speech model here? Like, some people think so, but I think for us, like, again, we still had a thing that we were trying to get to, and we were still excited to try and create that thing. And we thought, what are we doing? Let's keep going. We have some insights here. We'll push forward hard, and we'll see what happens. So
we'll see what happens. That's same for us.
Well, you can do, right?
Learning.
I think it's like, yeah. I was talking to one of our investors, and I was sort of saying, like, just talking through, like, sometimes, like, the only thing you can do is just build through it, right? Like, I think that when you're faced with, like, ambiguity or, like, uncertainty, like, you could sit there and do nothing, I suppose, and just, like, sit there and, like, ponder.
But there's no insight. There's no insight of just sitting still.
All you do is, I'm just like, my philosophy is, like, you just keep building. And again, as long as you don't, like, have this sort of like, oh, this is my precious baby, I can't. No, I think it's fine. So we're always experimenting with new things. And I think that's probably the right thing. I don't know. We'll see.
That's cool. You guys are my spirit animal. It's so peculiar to me listening to your talk, because it feels like it's like you're obviously much more research, different problem set you're kind of tackling with. but we have a very similar issue, or like we've had similar doubts, kind of FUD, let's call it.
Yeah.
And the only way to brute force through FUD is just shipping more stuff, just more features, more customers.
It's not, and it feels very intuitive to me too. I think like maybe we both come from like very buildery backgrounds, where like the only thing to do sometimes is like. But I think for it's not a. I think a lot of groups like sort of struggle with that, right? And you sort of sit there pondering, and you really want to build only the right thing. And I'm like, let's just.
It's like just build it. Just build something. Just build something.
Like we're gonna learn something along that journey, I guarantee it. And it's most certainly better than sitting here doing like twiddling our thumbs and be like, oh no, you know what we're gonna do. It makes your days much more fun as well.
Yes.
And so yeah, we do. I think we definitely have a strong builder culture, which I'm sure you guys do as well. So
same, yeah, very much. We convince ourselves and each other of bets by just shipping and being like, hey, how does it feel? Does it drive more outcomes? Can we drive more test case failures? That's the KPI. Can we find more failure modes that matter to customers? So de facto, anything that moves the needle is good. Just try it out. Just sort of own it.
ZQ, the thing I love, so ZQ is our chief scientist, and the thing that's really cool about watching ZQ work is he loves a good failed experiment. Like legitimately so. Enough that he'd be like, this is fantastic. I'm like, this is not fantastic. This looks terrible. He's like, no. We just learned this entire branch is not going to work. Like that's a very useful thing to discover.
It's super useful.
And so he has one of the best attitudes I feel like towards failure as a mechanism for learning. I always sort of said I remember at Google, I used to always sort of tell my teams they'd be like, we don't want to waste any time. Like there's no such thing as time wasting if you're building. Because I guarantee you are learning something in that build process. And so we should never sort of have that we wasted time philosophy, as long as we're pushing something forward and trying, because we are for sure learning faster than if we just sat here doing nothing. People love to kind of hem and haw about only building the perfect thing, and I think that's just very, very wrong. So
I think I have to give a shout out to YC actually here. The purest version of YC is this, which is you talk to customers or you build. And if you're not doing one of those two things, ideally simultaneously, you're doing both things at the same time. There's nothing compounding. Knowledge, insights, muscle, right? Sort of fear of failure, fear of rejection. Nothing is actually compounding. And learning is sort of the first thing that then translates into a product, which then translates into value, which then is become monetization. So I would say the YC, the general kind of pure version of YC is this.
What now? Now I'm curious what the unpure version is. What's the tainted version?
I think the corrupted version. The corrupted. Yeah. We'll leave it there.
Yeah, there we go. Exactly. It's there's the pure, but then there's that the tainted version. Yeah. Okay. Yeah. It's a separate topic.
Awesome. Well, look, this was fun. Thanks for just jumping on, YOLOing our way in a conversation.
The only way. Again, maybe I can't see. I'm always a big fan of the. Do you know the "Ethic will do it live" meme? It was I think it was the Bill O'Reilly. It's great. Everyone should look it up later because it's my favorite mechanism where it's you just can't get it right. He's like, okay, we'll do it live. It's always my MO. We'll do it live. It's the best way. So
it's
cool,
great.
man. Appreciate you having me on, and then it's fun to chat about these things.
Yeah. Enjoy, man. Bye.
All right, talk to you, man. Bye.